Now, let us see the second question on mole concept. Here also is a second example where we have to know which reagent is limiting. We have a limiting reagent. Okay? Because we are reacting chlorine gas with NaOH, EQ. We are getting this. So we want to find which reagent is limiting. And which reagent is emitting. We are taking that much of gas, we are dissolving in that much of alkali. Now, first of all, we have to convert both into mole. Okay, as in the previous question, we convert this into mole, and then we convert the acid into mole. See the previous video. Okay, now, here also we convert this into mole and this into mole. Now, this into mole, you know that all gases, all substances in the gaseous state occupy 1 mole. Okay, 25 centimeter cube, 74,000 centimeter cube of any gaseous substance occupy 1 mole. Okay, 1 mole. No, not occupy 1 mole. 1 mole of any substance. 1 mole of any substance in gaseous state occupy 24,000 centimeter cube. This is okay. 1 mole of any substance of in gaseous state. 1 mole of any substance in gaseous state will occupy 24,000 centimeter cube at room temperature and pressure. At room temperature and pressure means at RTP. At RTP means 25 degrees Celsius or 290 Kelvin. No, this is a temperature temperature, pressure, say room temperature RT is 25. This is okay. And pressure is 1 atmosphere. 1 atmosphere is 100 mil Pascal. Okay, 1 atmosphere. So room temperature and pressure. Good. Now, it occupies all substances, all gaseous substances occupy 1 mole of any substance. Okay, 1 mole occupy this. Now, what about 1 mole of chlorine? 1 mole of chlorine, if you take the periodic table, you will see that chlorine is 25.5. With 35.5 times 2, because there are 2 here, the molar mass will become 71 gram. 71 gram of chlorine in gaseous state will occupy that much. Okay, now 1 mole is the molar mass, okay, of chlorine, molecular mass. Now, you have 24,000 centimeter cube of chlorine, so 1 mole. Now, we want to know in that much, how many mole do we have? So, you take 144 times 1 divided by this, you will get 0.006. Okay? Now, what we have calculated here, we have converted this 144 centimeter cube of gas into mole. Now, what we have to do now, we have to convert this into mole. So this is the concentration. This is the concentration. Okay. So how we have done this? How we have prepared this? We have taken the molar mass of sodium hydroxide, which is 40, multiplied by 0.25, which is 1/4. So it becomes 4 gram. We have taken 4 gram of NaOH. We have dissolved in 1000 centimeter cube of water. This is what we call the concentration. Okay. Now we read this 1000 centimeter cube contain 0.25 mole. Now we have to find how many moles do we have in the 38. So we take 38 times this divided by 3, you get this. Okay, because the concentration is 0.25 mole per dm cube. So you take 1000 centimeter cube contain 0.25 mole. So 28 will contain okay. Now let us consider these two in the mole ratio. Mole ratio is what we have in front of chlorine and in front of NaOH. You have 1 here, we have 2 here. So let's start with 0.006. So in the mole ratio, in fact in maths, what we are doing here, we do the same thing on the other side. If we are multiplying this by 0.006, so we multiply this also by 0.006. This you should do. So you get this. Now, let us analyze this. Our question is, which reagent is limiting? What is the limiting reagent? So you have 0.006 will require 0.012 of NaOH. You can see that NaOH, we don't have 0.012. We have much less. This figure is less than this figure. This figure is less than this figure. So I want 0.12 NaOH for complete reaction with the chlorine. We cannot do this because you have only this. So do you understand this? So NaOH is the limiting reagent because we need 0.012. Do we have 0.012? No. We don't have 0.012 NaOH. We have 0.0095. We need more NaOH. Therefore, NaOH is our limiting reagent. Okay? So this is one question. One more question to find limiting reagent in a reaction given a balanced equation and given the mass or volume or concentration, and you have to convert to mole ratio. You have to calculate the number of moles on each one. Then you have the mole ratio. Then you consider which is the limiting reagent. Okay, a small revision here. Here you have mass. You have HCl. You are given the mass and the volume and the concentration. We convert this into number of moles and we consider the mass into number of moles. Then we do mole ratio. Then we see which is in excess, which is in limited. Okay.